Hello, welcome back to the continuing lecture in investments. So, so in our last video, we took a look at the derivation of convexity. So now we're going to look into the application of convexity. So, so let's go to the actual example, right? Of course, this graph is basically, telling you we are familiar by now that this captures the price movement, right? When interest rate changes, right? But and this is the curvature, right? The convex curvature that is captured by the exponential function, right? Continuous compounding, right? Or continuous discounting in this case. And this is the duration, which is, approximation of the, straight line appreciation, straight line approximation of the, curvature, right? And in our example, the duration is negative 11.26, and I've been telling you, duration is always negative, right? It's just, negative number, because of the the inverse relationship, right? Inverse relationship is always negative. Now, by using duration, this is how you would, predict the bond price change, change in, right? Interest rate times, duration will be changing, bond price. So let's take a look at the example 11.4. So in figure 11.5, this is figure 11.5. Maturity is 30 years. That's a long, very long, of course, that's, long-term bond, right? Coupon rate is 8%. Yield to maturity is 8%. Of course, then, the bond must sell at par value, right? Coupon rate and yield are the same. And if duration is 11.26 years, then at 8%, and if convexity is 212, right? 212. If interest rate changes to 10%, yield changes to 10%, right? Bond price will go down to 811.46, which will be an 18.85% drop. So let's see how duration and convexity, which one will work better in predicting this. Now, of course, duration and convexity are given here, but we're gonna verify this. We're gonna verify this. We'll have to verify, right? We're not gonna just let it we'll verify this, okay? Otherwise, it's pointless. Now, using, duration, then, we simply multiply, duration by change in interest rate, which is, 11.26 times 0.02, 2% change, right? Comes to negative 0.2252, which is, 22, negative 2.52%. By duration, the price change is, overstated because, when, bond price goes down to 811.46 from 1,000, actually, you can easily calculate that, the 1,000, how much did it go down? 1,000 minus, 811 is almost, one something, right? Calculate, 188, right? It dropped by 188, exactly by 188.54 in dollar value, right? 188. That's 18.85% drop. So it overstates, right? But then if we use convexity, right? So plug in, this is percentage change, right? In bond price, right? So multiply that by, just like, duration, right? And then have convexity, 212.4 times, square root, interest rate change, squared. Then it comes to 182, 18.27%, which is closer, much closer to actual drop in the bond price. So convexity is more accurate, right? That's of course it goes without saying, because we are trying to we are approximating it, right? We are approximating the we're calculating it according to this curvature. Okay. I'm not going to draw it. You know why? This is a straight line forecast. This is, but here it's 2% drop, right? Now, if the change is just very minor, insignificant, like 0.1% change, convexity would matter because we are in the range where it is pretty much like zero. This is 0.1% change would be somewhere here, right? And then very small change, and the linear, a straight line, linearity can, sufficiently capture the change in more, accurately, sufficiently accurately capture the change in the price. So using that small percentage, 0.1% is 0.001. The drop is negative 1.126. And if price drops just by 0.1%, a positive, it goes up 0.1%, and the price will drop to 988.85, which is negative 1.115%, right? So this is even by duration, this is quite close, and by convexity we are much closer. you get exactly negative 1.115, but the difference isn't that significant, right? But that's so convexity is quite useful, right? When um, the interest change is um, more visible, when interest change is more pronounced, when interest change is more um, obvious, right? For for a bigger change in interest rate, definitely convexity will give you a better prediction of the price change. So here, of course, this is another way of, another, formula for, which is, a lot easier, because it doesn't, uh, but again, this is, the same concept as, that's the same concept as this, right? Same concept as that. Um, so, interesting thing is, okay, I'm gonna talk about this in the next video because it's all together, when it comes to the benefits of convexity. So what I want to do is I want to do the Excel. Uh, I want to verify. I said, whether that duration was like that or not. I said I wanted to verify, right? So here, let me. Okay, so let's do this Excel file, which is, you would also find it in the convexity. You will find it in the our materials folder, lecture materials, course materials folder. Let me just quickly show you where um, uh, I think the file name is convexity. So I'm not gonna. It's in the our lecture notes folder, right? So I'm gonna. The file name is chapter 11 convexity practice. Okay, you will find it there. Now this is the example in the this is the example in the book, and I wonder if you can see that. Yeah, you can see it now, right? So let me. This is only 10-year example, 10-year. So let me. Okay, so basically, I'm using. Okay, let's start with. I'm using this convexity formula, right? Um, so this is discrete, right? In other words, the difference between exponential function and this is discrete time. And in reality, of course, the curvature is the result of continuous compounding, but this is the result of discrete compounding. But since if bond is paying, coupons, annually or semi-annually, of course, in terms of price, right? Um, of course, due to the demand and supply and constant, trading in the market, the bond price will show, continuous pattern. But I suppose we are just simply, assuming that prices, the bond is priced, at each uh, coupon payment point, right? So discrete time. Now, to use this formula, we will have to have, this is what, present value of cash flow, right? Present value of cash flow. So we'll have to find cash flow. And then we'll have to discount it. Present value is already discounting. And we'll need to find t squared plus t, and then product of the two, right? And then, divided by 1 plus y squared, right? So first, finding, so the coupon rate is 3%, yield to maturity 4.5, maturity 10 years. This price is already, I'm using, price formula for, price formula is, not the Excel's built-in price formula, but, as you can see, it's basically annuity, present value of annuity, plus, present value of the maturity value, right? That formula, right? So, cash flow is, $3. I mean, this is actually $30, right? This is not $88. You all understand. This is, $881.30. This is $30. Everything is, percentage of, 1,000, right? So now present value, it's not difficult. It's simply, this I1 plus yield to maturity, right? YTM. Yes. Right? And then you drag it down. There you go. That's why it is exactly. If you sum all of these cash flows, then right, that is basically that's the bond price, right? Now t times t squared, so it's simply we'll do that. Drag it down, and then the product of the two. And we drag it down, and sum of those, and then it's already built in here, but convexity is E17, which is this, right? Which is cash flow. I mean, E17 is bond price, right? Bond price. And since this is, this is the denominator, bond price times 1 plus y squared, so, right? Bond price times, 1 plus y squared, right? And then the whole thing, this is, this term is all captured in here, right? That's basically present value of cash flow times present t squared plus t, right? That's all captured here. So that thing being divided by this, okay? So this is basically a convexity calculation example. Now, what I want to do is I want to do the, I want to do, what did I want to do? I want to verify our example. Remember in our, so let me, in our example, what was that? 11.2 example, or 11.4, right? In our example 11.4, right? So the given, right? modified duration was given as negative 11.27, wasn't it? Yeah, 2.6. Okay. And convexity was 212.4 to 12.4. Okay. And I want to verify this. So I built a 30-year table, right? I built a 30-year table, and the process is the same. I built a 30-year table, right? And I also checked. So if at 8% coupon rate and 8% yield, because coupon is equal to the yield, then it should be exactly, par value. So sum of all these, discounted cash flows, it comes to 1,000, right? Oh, that's what I'm. Okay. Everything is, there's one more red dot, so I got rid of that. So let's do this. Actually, it's not a difficult thing. And it was not a tedious. I mean, 30 years is not easy. It's not that difficult to make. I just plot 1, 2, 3, and then drag it down, right? And then it will until I see 30, right? I'm going to show you again. So this is what Excel is good for. I just plant a few seeds of numbers, right? And then highlight, select those cells and oops, why is it only like that? Three. You have to select all those 3 cells and then drag it down. And what is going on? This is the problem with my mouse. Actually, if you just plant, 2 or 3 numbers, right, in series, and then just select all, and then highlight all, or select those cells and drag it down. Excel automatically generates the number series. The mouse that I'm using is, not very good. That's why it's happening. And cash flow, it's always, right? The mouse is sticky. And then you lock it and drag it down, right? And then, present value, it's not a difficult thing, right? And I'm not going to do this all over again because this is what we have, it's just, we already did this in the previous, it's just 30-year thing. But anyway, we divide this by 1 plus yield, and I'm going to have to lock it, right, so that it won't change as I drag it down and raise it to this. But this thing is you go, and I drag it down. Okay, and then here I already entered auto sum, so I'm just gonna do that. And this t plus t squared, simply not a difficult thing. And then I drag it down. There you go. And then these two terms multiplied, the product of these two terms. Okay, there you go. And this convexity formula, right? So what did I get? I got exactly 212.43. Now, let's check if our duration is also 11.26. Yeah, I used, Macaulay, both Macaulay and modified duration. Macaulay duration gave me, using the duration formula in 12.16, but modified duration gave me 11.2, 11.25. 78, which is 11.26, and it's got to be negative, right? So that way we verified. So let me switch back to okay, you must be seeing this just about. Where is it? Yeah, just about now. Okay, so we verified, right? These, numbers, and this brings us to the, conclusion that convexity is very absolutely necessary when interest rate changes, are significant, right? When interest rate change is minor, right? Duration does a good job. But if it is, interest rate changes, significant, we need to use convexity. And also, the benefit of convexity is that higher convexity, when convexity is high, right, bond increase in bond price is greater than the decrease in bond price when interest rate fluctuates by larger degree than smaller degree. In other words, it's not symmetrical, it's asymmetrical. In other words, when interest rate goes up, right, the bond price will go down, right? And when interest rate goes down, the bond price will go up. Look at, suppose, interest rate went down by 5%. If interest rate went down by 5%, bond price went up by 100%. Of course, once again, this 5% means 5 percentage point, 5 percentage point, right? And this changes, percent. In other words, if the price was, $500, right? The price would be, $1,000, right? But look at the same degree of interest rate change. If interest rate goes up by 5%, how much the price drops? The price dropped only by about, even not 40%, right? Less than 40%. So what can you see from here? What can you tell? Even with the same magnitude of change in interest rate, right? When interest rate goes down, the price going up is the magnitude of price change going up, right? Is greater than price going down, the magnitude of price going down when interest rate goes up by the same degree, right? Makes sense? This is the one benefit of high convexity, right? This asymmetry raises overall expected return on the bond portfolio. Now think about it. Yeah, if it is symmetrical, they will cancel out, right? This upward, downward changes in bond price will cancel out when overall interest rate change on average is the same, right? In other words, overall interest rate. Think about it. It can. This is the variance of interest rate, right? Interest rate changes 5% positive and negative. Once positive, once negative. Let's say. Then, if the magnitude of change in bond prices are the same, then they will cancel out, right? But since it's asymmetrical, and the upside in the bond price change is greater than the downside, overall expected return is higher, right? Makes sense? So that's that's one of the benefits of convexity. Convexity is not for free. Investors will have to pay more and accept lower yields on bonds with greater convexity. So greater convexity means what? More variance, right? More variance is risk, right? It's riskier. Convexity is not for free because higher convexity means higher risk. Okay. If the combined convexity and duration is high, so is the risk. That's what I'm saying. If low, the book is hedged, right? If the combination is low, the book or portfolio is hedged, right? And loss is minimal even if fairly substantial change in movements occur, right? Okay, and looking at the why? It's because of the algebraic sign. Look at the algebraic sign. One is negative, the other one is positive, right? And if that is low, I mean, they would have, they may be even offsetting if, under certain conditions, but, they may not perfectly offset, but the point is, because they have opposite algebraic sign, when they are sufficiently offsetting each other, or partially offsetting each other, it will be low, and then it is hedged, meaning. But then obviously if you, the price change in the bond will be also small, right? All right, so that is the convexity, right? And how the application of convexity. So I'm gonna have to stop recording, and I will see you in the next video. Thank you for watching. Take care.